Hello everyone. In the previous class, we have seen that how to pre-process data. It's a part of our pipeline, right? If any data comes, how to can do data pre-processing. In today's class, we are going to see the next pipeline or next step in the pipeline, which is called feature extraction. Okay, so let me explain again the pipeline. Okay, let me talk about okay, our NLP pipeline. I have already covered that, but let me again remind you what the pipeline I'm talking about. Okay, so as we discussed that initially, what the first step is the data. We acquire the data, right? Data acquisition. This is our first step in the NLP pipeline, right? Second is data pre-processing, which we cover in our previous chapters, previous classes. Data pre-processing, which already cover. Okay, so for the data pre-processing, we saw what we call NLTK, right? There are multiple library we use. We use NLTK library. We can use sparsity library, which okay. There are multiple things we can use RE module. Okay, so the whole purpose of to clean the data, the output of this phase is to just to clean the data. After that, I think as of now we have seen this part, right? Now in today's class we are going to see which is the next step is the feature extraction. It is called this is the next step in the pipeline, feature extraction. Okay, this is very important. And after the feature extraction, the last part is called model building, which I will cover. Okay, model building. Okay, so now let us focus on this portion, which is very, very important, which we are going to cover in this class, feature extraction. Okay, so why, first of all, let me talk about feature extraction in detail. So why we need feature extraction? Okay, feature extraction. So whole purpose of feature extraction is what? To convert text into numbers, right? Because in NLP, our source is a text, but our computer don't understand text, they understand numbers. So in order to build a model so that our computer can understand our text, we have to convert into numbers, right? So how to convert a text into number? For that, we apply feature extraction. So in order to convert text into number, there are multiple I would say multiple model or multiple concepts which which you have to learn in part of NLP. Okay, so there are multiple things. For example, there's a bag of words. It is called B or W. In form, it is called bag of words. This is important technique. Okay, concepts which helps to convert my text. Okay, which is clean text. Okay, into number. Another is called which is another you can say a new variance of bag of word. It is called n-gram. We will see that how to use n-gram. Okay, these concepts. So bag of word is concept is there. It is a part of feature extraction. N-gram is there, which is a part of feature extraction. And then this is another concept called TF IDF is there. This is also very important feature extraction technique. Okay, we will see that in upcoming classes, how to use TF IDF. Okay, and yeah, this much. And actually this all technique like bag of word, n-grams, TF IDF, these are based on, I would say, a statistical model. They depends upon the statistical model. Okay, apart from that, there are some neural network kind of, these are based on neural network, and which we will see. We will learn what is neural network, deep learning. Okay, so this model which I'm talking about right now, these are based on the deep learning model or neural network. Okay, these are not on deep learning. These are basically a statistical kind of model. For example, which I'm talking about neural network. For example, it is word to wake. Okay, this is also very word to wake. Okay, WEC, word to wake is another model which is it also help to convert my text into embedding or numbers. word to vec model, but it is based on neural network. Okay, there is a globe also. So these are some technique. So these are some these are, you can say, these are some feature extraction technique which helps our text to be converted into number. The whole idea, so the whole purpose is convert my text into numbers so that I can build a model and my computer can understand this number. Okay, I hope the context is pretty much clear. What is the feature extraction, and this step, why this step is required after cleaning the data. This is the third step, feature extraction. Okay, so now in this class, let us we will see all bag of word, n-gram, tf, idf one by one, and then we will word to vec, these all things we will cover word to vec globes once you have the deep learning concepts. Okay, so now in this class I'm going to start bag of words. Okay, let us see this technique, how this technique B or W, bag of words, work. Okay, and what are the basic concepts behind word to vec. Okay, and how it helps this technique to convert my text. The whole purpose is converting text into vector, or you can say a number, so that my computer can understand and I can build a machine learning model. These are the whole concepts. Okay, so let us understand what is bag of words. Okay, its very idea is very simple. It's very simple idea. Bag of word is very simple idea. Okay, so in order to explain that, I'm taking some example. Okay, I will do practical also. Okay, but here I'm just explaining. For example, let's suppose I have these three texts. Okay, data gigs teaches NLP. Data gigs. So I'm taking this example so that I have already some practical around that. So data gigs teaches NLP. Let us see. Okay, data gigs teach NLP. Let's suppose this is my first document. Okay, this is my first document, D1. This is D1, and D2 is. I hope you guys understand what is corpus, what is document. This all thing I've already covered in previous classes. So I hope you have the understanding, right? Okay. Next sentence is NLP is in demand in market. NLP is in demand in market, right? NLP is in demand in market. This is my second document. Third document is, let me copy there. We have to learn NLP. Let's suppose this is my third document. We have to learn NLP. We have to learn NLP. Okay. So this is my three documents. And this is a whole thing is called corpus. I think these all thing I have already covered, the basic thing. So this is my whole corpus. This is my whole corpus. And this is my three document, D1 plus D2 and plus D3. These are my three documents. Okay. So how the bag of words concept works for this, you have to also we had covered like the vocab, right? Vocabulary size. Yeah, it is, in short we call it vocab. Okay, these things, my friend, I have already covered. These are the basic foundation. If you're not aware of this term, what is corpus, what is document, what is observation, what is vocab size, then please go and watch our previous classes recordings. But I have covered that. Okay, I hope you have the understanding. Now, how it works. Okay, so what happens, let me make it simple. Okay, so how the machine works in bag of words, what we do. Okay, first, this is the first step. Okay, the step number one. Okay, one thing, whatever I'm talking about, all the steps you don't have to do manually. Okay, we have a library and we have already written library which does everything. But here why I'm doing everything manually, just to explain the concepts so that we have the basic understanding. But don't worry, this all manual work you don't have to do manually. Okay, so first step, we have to prepare vocab. What is my vocab? Okay, so what is the vocab? You understand, vocab is a unique words, list of all the unique words in your corpus. It is called vocab, right? So here, what is my vocab? Let me first I need to prepare a vocab. Okay, so you can see that data gigs. This is one word, one token. Okay, so this is one token. Data gigs. Teach is another token. NLP is another token. NLP already taken, right? So here I will prepare a vocab. So I'm preparing a list of tokens. Suppose data gigs. Data gigs is my one token. Okay, one vocab. Teach is one vocab, right? NLP is another vocab, right? So this way, machine you don't have to do manually. This all thing is prepared. Okay. Then okay. Then in the third one, the second sentence, second document, NLP I have already taken, right? So NLP I will not repeat because I need to prepare unique words. The vocab talks about the list of unique words. So NLP I have already taken. So from the next document I will not take it. Is okay. I can take is. This is my is. Another vocab. In I can take in. Demand, right? I can take demand. Another vocab. In already taken. I will not take market. Market can be my another vocab, right? V is unique. Okay, I can take V. Have I can take another vocab. Two is not there, right? Two is unique. Two I can take. Learn. Learn we can take another vocab. NLP already taken, right? So these are my friend. These are my unique vocab. Okay, so for this corpus, for this document, these are the unique vocab. I hope till now it is clear. Okay, now so how the word of bag bag of word work? Let me make it little bit smaller so that I can get some space. Okay, all right. Okay, so what the machine will do? So let's suppose this is my vocab. Okay, I have already prepared. Okay, now here I have to give a for each let's suppose for each document or for each sentences. Okay, for each observation I have to give a representation. Okay, a representation of each word against the vocab. This is my vocab. Okay, suppose this is a sequence of vocab. Okay, data gigs, teach, NLP, is, in, demand, market, we, have, to, learn. Let's suppose this is my vocab size or sequence of vocab. Just keep it simple. Okay. Now here, if I want to represent my D1, this whole sentence, for example, data gigs, teach, NLP, I want to represent is numerically in number. Okay. So how I will represent? So here you can see. Suppose this is my vocab which I prepare. Okay, so data gigs. Okay, so this vocab data gigs matches with first word. Okay, so in order to so D1, okay, I will represent D1 in number like this 1. So if I'm matching any word, I'm giving 1. This is like a one hot encoder, if you know that. Okay, teach is my vocab. Is the teach is the part of document? Yeah, it is there. So I will give 1. NLP is my vocab. Is the NLP is a part of document? Yes, it is there. Then I will give 1. Right? Is this vocab is the part of first document? No, right? You can see the first document. It is only data gigs, teach, NLP. There is no in, is, right? So for the is vocab, I will give a 0. You getting this? In, again, for in there is no in. I'm giving 0. For demand, there is no demand in first document. I'm giving it 0. So the vocab which I'm not finding in the corresponding document, I'm representing as 0. It's very simple. Market, I'm giving 0. V, I'm giving 0. Have is there's no have in the first document, I'm giving 0. To, there's no to, I'm giving 0. Learn, there is no learn, I'm giving 0. So this way, the data gigs, teach, NLP, this whole document, this whole sentence can be represented with respect to, again I'm repeating, with respect to this vocab like this, right? 1 1 1 0 0. It means that One represent data gigs, one teach NLP. You got, I hope you're getting the point, right? Now think about D2, second document, right? Data gigs, my vocab is data gigs. Is data gigs is there? No. So I'm represent as a 0. Teach is there in the second document? No, I'm giving at 0. NLP is there? Yeah, NLP is there. So I'm giving 1. I find 1 NLP. Okay. Each is there? Yeah, is there. I'm giving 1. In is there? I'm giving 1. Right? Demand is there? I'm giving 1. Right? Market, yeah, market is there? I'm giving 1. Right? V is there? No, I'm giving 0. Have is there? No, I'm giving 0. To is there? No, I'm giving 0. Learn is there? No, I'm giving 0. Right? So D2, this whole document can be represented in this format with respect to my vocab. Okay. Now think about D3. Okay. So my vocab is data gigs. The data gigs is there in this document? No. So I'm giving it 0. Okay. Teach is there? No, I'm giving 0. NLP is there? We have to learn NLP. It is there. I'm giving 1. Is there? No, giving 0. In is not there, giving 0. Demand is there in the third document? There's no demand. I'm giving 0. Right? Market is not there in document 3. I'm giving 0. V is there. I'm giving 1. Have is there. I'm giving 1. To is there. I'm giving 1. Have is there. I'm giving 1. Right? So this bunch of text, which is document 1, document 2, document 3, is everything I'm representing like this into numbers. Okay, and how I'm preparing this number, this is based on with respect to my vocab size. So first I need to determine what are the vocab size, and based of the vocab size, it will present the whole thing into numbers. Okay, and now I will feed this number, okay, whatever number I prepare. So this number look like a matrix. If I see mathematically, this everything is a number, right? And what is the features? How many features? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So what is the vocab size? What is my vocab size? Vocab size. Okay, you can count here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? So my vocab size is 11. Okay, so whatever vocab size you have for your training data, same number of features, because in machine learning we call it feature, right? These are column, right? This is the first feature, second feature, third feature, dot dot dot. So if it should match with the same vocab size, the number of feature. Okay, so I have going count here, it is 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I have 11 feature, and because I have 3 observation, 3 documents, so the size of this matrix will be 3 into 11. Any question, any doubt here? So this is how I represent my text, my whole document in terms of number with respect to my vocab size. This is the representation. This is the numerical representation, or you can say vector representation. And this is called, this vector has a special name. Okay, it is called a sparse matrix. We call it sparse matrix. Why we'll call it a sparse matrix? If you know, if you understand NumPy, okay, because it has multiple zeros. You will find that in a sparse matrix, this is the nature of a sparse matrix. You will find what? You will find more zero and less one, less number. Okay, less number or less one. So you can see that it is more zero. So it is called a sparse matrix. Okay. So this is how, this is called a bag of words. So this is how we use this technique to convert my text into numbers, into a sparse matrix. Okay. The problem here is that this gives a sparse matrix, and a sparse matrix has some limitation, had some problems. Okay. I'm not going in that detail what is the problem, but the basic problem is that we have multiple zeros. Okay, so it will take a lot of I mean, zero has no information, right? But it will consume memory uh, because we have to store these values, right? And the computation is very difficult here. There are a lot of things happens. So generally sparse matrix is difficult to deal. Okay, so that is the problem. And there's one more problem here. Though it is very simple, okay, word of bag representation is very simple. That is the prawns. That is the pros of and the advantage of bag of word. Okay, the advantage is what? It is very simple to use, simple to calculate. Is very simple. Okay, but the problem is the cons for this. Okay, the problem is that the result is called a sparse matrix, and generally we don't prefer sparse matrix. The calculation is not easy. Okay, and the second concept I want to talk about is called out of vocab. Okay, this is important concept, out of vocab. Okay, let's suppose the problem here is that I can see that this is my training data, right? This is my, let's suppose I'm training my model. This is what I have text. Okay, this is the d1, d2, d3. These are my texts, right? Let's suppose something, suppose I build this model, and my model is able to understand this text, this because this is the part of vocab, so they can understand. Let's suppose something in the test data or in the live data, something comes, for example, uh, let's suppose I'm giving, suppose it can, suppose any number. Let's suppose rocket science. Okay, suppose rocket science. Okay, in my text I have this word called rocket science. Okay, rocket science. So this rocket science, you can see that it is not the part of any training data. It is not the part of vocab itself. Okay, so who are the part of vocab? My model understand this vocab: training, data, gig, stake, NLP. These all the vocabs. These are part of vocab. But this rocket science is not the part of vocab. Okay, so these words, this is quite chance, right? This is quite possible, right? The training which you're training, maybe they're in the run time, maybe at the test time. Okay, at the test time, when you're using the model, the word or the token which you're using just to predict the for the prediction or finding the value, maybe these words as the test data, they have, your model have not been trained on those data, those inputs, because maybe these words are not the part of vocab. So those things is called out of vocab. Okay, and here in bag of word, we have no any representation. We cannot I mean, there's no special representation to deal with such things, such out of vocab. Okay, like another model like word to vec, they have a special way to treat it. They have a special mechanism, but there is a chance that if something is not matching, they will become zero. Okay, they will become zero. So this zero means here, I mean, it can be word of vocab. I don't know. This zero means maybe it has no representation. Okay, but you can see that here, if I see, for example, here in the first document. Okay, what is my first document? Data gigs teach NLP. This is my first document, right? So here this zero, okay, this zero says this zero is what? Data gigs teach is. Okay, this zero is. So here saying that is this is a part of vocab. This is a part of vocab. It is in the vocab, but this is not in the document. It is a high chance, right? It's possible. But how to represent vocab out of vocab? Okay, which is not in the uh, in the in the training data. It is not in the my vocab. So this is the problem. Okay, so these are some terminology you have to remember. Okay, but in the nutshell, how it works, word of vocab, word of bag. Okay, bag of words. This is the how it represents the matrix. Okay, and how it prepared on the basis of your vocab. We have already a library for that. Don't worry, you don't have to prepare this everything manually, like vocab size and building the vocab, on building the matrices. You don't have to do manually. we have a library for that. Okay, but in this class I wanted to cover the basic understanding what is bag of word and how it this matrix is how this matrix is prepared. I think this understanding you should have. Okay, so I'm assuming that guys you have the understanding how to build this matrices and how the word of bag use the technique and prepare the sparse matrix. And this sparse matrix I will showcase some project. I will build a model, machine learning model based on this input. Okay, and I will do prediction. Okay, so this is the concept of bag of word. Okay, and in the next class I will give some I will do a project. Okay, and we will see that how to use it. Okay, but before that, okay, one more thing before we go in the project session. Okay, here what I discussed right now, this is only very theoretical, right? But really how in the code, how to implement this code, let me explain that. Okay, but I hope you got the understanding, fair understanding. Okay, now let us see in the action. Okay, the same thing which I gave the example. I told in the beginning, right? You don't have to do any manual stuff. You don't have to prepare manually the vocab. You don't have to prepare the matrices manually. Everything is done by machine learning. Okay, we have a library for that. Okay, so here just to demonstrate whatever I discussed theoretically, just to demo the practical concepts, I'm using some sample word. Okay, sample documents. Okay, so it's very simple. I'm importing numpy panda, and this is my document. Okay, just for explaining, just for demo purpose, I'm using this text. Let me run this. Okay, I'm creating a data frame like this, very simple. Okay, so I have three documents, the same example I gave in the theory. So I have three document. Data gets teach the same thing. Okay, so how for this document, how to prepare the matrices, the sparse matrix, how to prepare the vocab, you don't have to worry that. So for that we use count vectorizer. It is a part of a scikit-learn feature. Okay, scikit-learn dot feature extraction dot text. We use count vectorizer. So count vectorizer is kind of, okay, one thing I want to put in your mind, that count vectorizer is the implementation of bag of word. Just remember, okay, this concept. Okay, a lot of people get confused. So count vectorizer of scikit-learn, it's an implementation of bag of word. Okay, these things I hope you remember, right? This is how it is represented and scikit-learn. Okay, so here I'm using count vectorizer. Okay, and okay, one more thing, bag of word has two versions. Okay, let me talk about that also so that I can explain in the coding. So bag of word has two versions. Okay, one is called count, and one is called binary. Okay, what is the difference between count, bag of word, and binary? So let me give a demo. Let me explain that. Okay, but these are the two important versions. Okay, so here you can see that if you're creating a count vectorizer, okay, and you're just creating the instance. Okay, and here I'm not passing anything. Okay, so this one is called count. Okay, so CV, the first one, the CV I'm creating without any binary true. If you're passing binary true, then it is a type of binary. It is a type of binary bag of word. Otherwise, it is a type of count. What is the difference? It's a very slight difference. I will talk about that. Okay, but yeah, if you're not using any parameter like binary, then it is a count type. And if you're using binary is equal to true, then it is a binary type. Let us see what is the difference. Okay, very simple. Okay. So now I'm creating the count vectorizer. Okay, and whatever text I have, okay, this I told, right, I need to convert whatever text I have, right, whatever text I have, these things, let me make it smaller. The first step is what? I need to prepare a word vocab size. I need to prepare my unique vocab. This is important, right? So how to do that? So that is why we use count vectorizer dot fit transform, and we passing there all my data. This is what, very simple. Okay, if you apply fit transform, passing the data, it will give you vocab and it will give you the sparse matrix. So this line, this simple line is doing everything for you. You don't have to do any manual stuff. I hope you're getting my point, right? So here I am creating a count vectorizer. I'm just doing fit transform. I'm passing my data, text data, and this will convert. This will give me I'm just giving a name bag of word. You can give any variable name. Okay, this is up to you. So here I'm giving a bag of word one, bag of word one, and okay, bag of word and one. Okay, so the first one, this is the count, because here I have in the first one in the CV, I'm not using any binary, so it is a count vector. Okay, this you can say that it is a count BOW. This is a count bag of word. Okay, and the second one which I'm using binary true, so this is the binary bag of word. Okay, the difference I will come again. Okay, so let me run this. I just did a fit transform. Okay, let me run the first cell. Okay, so it is creating the count vectorizer. Okay, then I'm doing the fit transform. Okay, it is done. Okay, now let me see. I told right it will create the vocab for you, unique vocab, and it will create a sparse matrix. So let us see. Okay, so how to find all the vocab? For example, I'm giving example of first one, which is a count one. Okay, count bag of word. Okay, so here for this CV, for this count vectorizer, okay, there's a property called vocabulary. Okay, so if you run this, right, so for this CV, okay, what are the vocab size? I mean this one, this vocab. I want to prepare this unique vocab size. So this one, it will give you vocab size. Okay, for the CV, for the first one, these are the vocab size. So data gigs, teaches, NLP, is, in, demand, market, we, have, to, learn. If you count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? The total size is 11, right? So exactly same thing I did manually, right? You can see that this is my vocab size, right? So same thing I get from here. Total my vocab size is 11 unique tokens, right? This is what I got, right? Yeah, here I'm doing some couple of programming here. What I'm trying to do here, I want to arrange this token, this vocab into uh, increasing in a sorting order. I want to sort it in the increasing order of uh, their sequence. Okay, so they are called indexes. Okay, so internally they are representing the data gets at 0 position. Okay, so they maintain an index for every vocab. Internally they maintain an index. So this vocab where I need to keep at what index. So this is 0 in nothing but the index. Okay, so data gets at 0 index. It's just an index. Okay, so what I'm doing here, I'm just sorting. I'm applying a sort function, sorted. Okay, I'm just sorting it. So whatever vocab I have, okay, I'm applying vocab items. You can see the vocab. This vocab has one function called items, because this vocab is just like a dictionary. You can see that it is just a dictionary. Okay, so dictionary is a key value pair. So key is my word and value is the index. So this has a one function called items, just like because of dictionary, right? If you know the Python, right? So here what I'm doing, I'm just sorting my items on the basis of increasing order of their index. So this way I will get the index of each vocab, right? So index 0, data gigs, index 1, demand, 2, have, 3, in its way it is arranging the whole vocab in the increasing order of the my index. Very simple programming, right? So as of now I got my all the vocab in the increasing order, right? Now I told, right, the second part. So I got my vocab till here it is clear. Now I want to see the numerical representation, how this word, each document has been represented in terms of array or in terms of matrices with respect to my vocab, which I did right now, right? So how to see that in the code? Very simple. So I got my vocab, okay, and here BOW, which is my bag of word, this one, okay, it will give you array. Actually, it is an array. Okay, so here I'm printing the first array. I told that depends how many documents you have. I have 3 documents, right? I have 3 documents, so it will prepare three array, right? So this is what I'm getting. I'm pulling. I want to see the array, right? So I'm pulling the first array BOW0 first index, and it will show me this, right? So it is okay. Let me explain that. So how it is preparing? Okay, you can see that the first index is data gigs, right? My first document. My first document is what? Let me. This is my first document, right? Data gigs teaches NLP. Let me explain this. I have already explained there. Okay. Okay. Already I've written. Okay. So let's see that this is my first document. NLP data gigs teaches NLP. This is my first document, right? So this document has been represented in this array format. Okay. How it is doing? It is doing on the basis of your vocab. Okay. So now my first vocab is data gigs. This is the first index. So it will check. Okay. Data gigs is there. It is there. So it is coming 1. Demand. Demand, it is coming in my document? No, it is giving 0. For a have. Have is there in my document? No, it is giving 0. In is there in my document? No, it is giving 0. Learn is there? No, 0, right? Same concept, right? Market is there? No, 0, right? Last one, you can see this one. 1 is what? Last third. I mean teaches. So teachers is there, right? Teachers is there in my document. It is matching. So for teachers, it is giving 1, right? 2 is matching. No, 0. And have we? No, 0. Same concepts. Okay. So what I discussed theoretically, okay, the way I prepare this matrix, this row with the 1 and 0, same thing it is doing with the code. I hope you got this right. So I hope you got the concept how to get the vocab and how it arranges the vocab in the increasing order, and finally how it prepare the matrix with respect to the vocab size. This is clear, right? Same thing for second row, third row. One thing I wanted to talk about this concept. What is a count? I discussed, right? There are 2 types of Babel word. Okay, one is called count, one is called binary. So there's very basic difference. One is called count and binary. Okay, in case of count, what happens? It will count the actual how many times any token are repeating. Okay, in the given document, it will this count. It will count the occurrence of token in the document. This is the only difference. Okay, it will give a number. It will total count. And binary, it will just give 1. No, I mean, if it is repeating 2 times, it will suppose any token is repeating 2 times. Okay, so count will give you 2 because it is repeating 2 times. But binary will give 1 1. This is the only difference. Okay, 1 1. Let me explain. Let me show that. Okay. For example, if you see that the if you see the second array, okay, here 2, okay, so so for example, see NLP in the demand in the market, right? This is my document and this is my vocab. Okay, so data gigs is not there, so it is giving 0, right? And demand is not there in my document, it is there, right? It is giving 1, right? And have, there is no have, it is giving 0. In, just focus on in, right? So in this token is repeating 2 times in my document. In, right? So that is why for in it is giving you 2. This in which is the vocab, it is repeating in my document 2 times. So that is why it is giving a count. Okay, otherwise it will give 1. Okay, because this is the count back. This is the count backward BOW, right? That is why it is counting that token, the vocabs into my document, how many times that vocab is repeating in my document. So that is why you're getting 2. Okay, so here, I mean, it say that in is 2 times repeating. This is the only difference. Okay, otherwise there's no repeating. Okay, so this is the basic difference. But in case of suppose, okay, now let us see the second case of binary BOW. Okay, BOW1. So in case of binary, the second row, let us see the second row, right? Second row, BOW. So this is the BOW1. This is the binary one. Okay, you can see that binary one, here it was coming 2. In was for the in, it was giving me 2. It was counting 2. But here in the in, it is giving just 1. So this is the only difference. Okay, so in the count, it will count the occurrence of vocab in the document. Otherwise binary, it will not get, it just give 1, or either 1 or 0. Okay, so this is how it works. This is how uh, it create the vocab. So there are two important things before I wrap up this class. Two important things you have to understand how the BOW work. First thing, the vocab. Okay, it creates the vocab for a given documents. Okay, for a given document, given corpus, it will create a unique vocab, unique number of tokens, which is called vocab. And based on the vocab, okay, it will find the occurrence, it will find the presentation of this vocab in the document. If it is finding the presentation, it will give number 1, otherwise 0. This is the only concepts. This is how BOW, bag of words, work practically, and I have shown through the code. And to implement that, we have to use count vectorizer. It has two variants, count and binary, and this will prepare your vocabulary, and it will give you a sparse matrix. So it is a sparse matrix. Okay, now in the next class I will discuss how to use it. We will do some project around it, and we will build a model, and we will see how to do some kind of analysis with the NLP project using bag of word. Okay, this is all in this class. I hope a lot of idea. I will see you in the next class with the practical with the project or bag of word. I will see you in the next class.